Hello everyone, welcome back to our channel Problematical. Today we'll start with the first exercise of your second chapter, Polynomials from class 9th Maths NCERT. Now in exercise 2.1 there are 5 questions. We'll understand the questions as well as solve them in detail. First question is, which of the following expressions are polynomials if one variable and polynomials in one variable and which are not? State reasons for your answer. That means you have to check whether the polynomials are in a single variable. So this is simple. By observation, we can say that your first polynomial, 4x squared minus 3x plus 7, is in one variable, is in variable x. Second, and which are not. So this is definitely in a single variable x. Second, state reasons for your answer. Now you have to justify why do you think that x is the only variable. So it is fairly simple by observation. Since all the terms contain only a single variable x, hence it is a polynomial in a single variable x. Second, as you can see, all the terms are expressed in terms of y. The second polynomial, x squared plus root y in your root 2. In your first term, you have y squared. In your second term, you have root 2 constant, which can be written as root 2 into y to the power 0. The same can be done for the constant of your first polynomial, 7x to the power 0. Since all the terms are in only variable y, hence it is in one variable y. Third, 3 root t plus t root 2. Now they've asked which of the following polynomials, which of the following expressions are polynomials in one variable. That means apart from judging whether they are in a single variable or not, you also have to state whether they are polynomials or not. As you can see, this can be written as 3 into t to the power 1 by 2 plus t into 2 to the power 1 by 2, but we'll leave it as root 2. The power of t in the first term is 1 by 2. Now, the power of t should not be anything but a whole number. So, t in the power of 1 by 2, power of all the terms of the variables in every term of an expression should be a whole number. Whole number means 0 or greater than 0 for the expression to be a polynomial. Since power of t is 1 by 2, which is not a whole number, therefore 3 root t plus t into root 2 is not a polynomial. If it is not a polynomial, we further do not have to check whether it is in a single variable or not. Next, your fourth is y plus 2 upon y. So here also you can write this as y plus 2 to the power 2 into y to the power minus 1. Again, the power is not a whole number. Minus 1 is not a whole number. So it is the same justification. You have to write the same words, the power of all the variables, and then the power is, instead of 1 by 2, you will write minus 1 for t. since -1 is not a whole number. Therefore, y plus 2 upon y is not a polynomial. Instead of just writing polynomial, you can also write polynomial in one variable. Fifth, x to the power 10 plus y cube plus t to the power 50. Now, this is a polynomial because all the powers are whole numbers, but as you can see, the first term has variable x, second term variable y, third term variable t, so it is a polynomial in 3 variables. Question is it a polynomial in a single variable? Your answer will be no. It is not a polynomial in single variable. The justification would be the first term has variable x, second term has variable y, and third term has variable t. Next question, second. Write the coefficients of x square, this is x square, in each of the following. That means you have to write the number in term of x square preceding x square, or the constant value of the term which contains x square. The first one, you have 2 plus x square plus x. You have 3 terms, 1, 2, and 3. The term containing x square is x square itself, so it has nothing before it. So coefficient of x square is equals to 1. Second value, 2 minus x square plus x cube. Now here you have minus x square. Minus sign goes with the coefficient. So coefficient of x square is equals to -1. In the third one, you have pi by 2 x square plus x. Coefficient of x square is equals to, now x square is preceded by pi by 2. So pi by 2 is your coefficient. Pi by 2 is a constant over here. Next, root 2x plus 1. If you can see, there is no x square term. So we will generate an x square term by considering 0 into x square. Because 0 into x square is 0, and you can add anything. You can add the polynomial with any number of zeros. Your polynomial will still be root 2x plus 1. So coefficient of x square over here will be equal to 0. Next question. Give one example each of a polynomial of degree 35 and of a binomial of degree 35 and a monomial of degree 100. One example each of these two. So first it says a binomial of degree 35. Binomial means you have to have at least 2 terms. Degree 35 means the maximum value of your variable has to be 35. We will consider a binomial in a single variable just for simplicity. So here you can have x to the power anything which is less than 35, say x to the power 7. You can write any coefficients. So I'm taking 2 and minus 5. So this can be an example of a binomial with degree 35. Second, a monomial of degree 100. So you have to have a variable and the power of variable is 100. Monomial means a single term and its coefficient can be anything. So let's say 3. Next, write the degree of each of the following polynomials. Now, in the first term, your polynomial is 5x cubed plus 4x square plus 7x. The terms you have are 5x cubed, 4x squared, 7x. Amongst these, the highest power of your variable x is 3 covered in the first term. highest power of x in the three terms of the polynomial is 3. Other powers would be 2 and 1 respectively. Therefore, degree of p of x, I'm calling this as p of x, is equals to 3. Second, 4 minus y square. Now, by observation, this is a constant term, y to the power 2. So, degree here would be degree of the given polynomial is equals to 2. 5t minus root 7. Now, root 7 is a constant, so the variable term is 5t, t to the power 1, hence degree is equals to 1. You should not write degree as how I am writing. The explanation of the first question should be repeated in each of these sub-questions. Now 3 is a constant, so it can be written as 3 into x to the power 0. So degree is equals to 0. Next, classify the following as linear, quadratic, and cubic polynomials. First, x squared plus x. There are two terms over here, and degree, two terms over here, it is in a single variable, and degree of the polynomial is equals to 2 by observation. Whenever you have degree 2, it is a quadratic polynomial. This is a shortcut way to solve it, but you will have to write the whole statement. So your presentation wise, this is how you'll write. The highest degree, the highest power or exponent of variable x in x squared plus x is 2. Therefore, degree of given polynomial is 2. Therefore, x squared plus x is a quadratic polynomial. This is how you'll present. Second question, you have x minus x cube. Here the degree is 3. Highest power of x is 3. In first term, the power of x is 1. Second term, power of x is 3. Degree is the highest power, which is 3. So it is cubic polynomial. We will present it as we did in the first part. Next, y plus y square plus 4. Degree is 2. Y to the power 1, y to the power 2, y to the power 0. Highest power is 2. So degree is equals to 2. 2 means it is quadratic. Next, 1 plus x. The power of x is 1, which is maximum power. So degree is equals to 1. It's a linear polynomial. Uh, 3t and r square. Now this is t to the power 1, which means it is again degree is equals to 1, and that will be linear polynomial. R square, degree is equals to 2, quadratic. Last, 7x cubed. Power of x is 3. So degree is equals to 3. It's a cubic polynomial. So that ends your first exercise. We will continue in the next class. Thank you.